Now, example based on the motion of charged particles. Normally, all these things are carried out in a cyclotron. A point charge of q coulomb is moving along a circular path of radius r meters at the rate of n rotations per second. Magnitude of magnetic induction at the center of circle in Tesla will be how much? From any point on the circle, charge flowing or circular current per second will be I is equal to nq, where n is the number of rotations, q is the charge. Magnetic induction produced at the center due to circular current is B is equal to mu naught I over 2R. Compute the values. The value comes to be 2 pi nq over r into 10 to the power minus 7 Tesla. An electron is projected with velocity of 10 to the power 5 meters per second at right angles to magnetic field of 0.019 Gauss. Calculate the radius of circular path described by electron. The mass of electron is 9.1 into 10 to the power minus 31 kilogram, and the charge of electron is 1.6 10 to the power minus 19 coulomb. For your knowledge point of view or information, you will remember that the ratio of charge and mass of electron was found by J.J. Thomson, and the charge was estimated by Millikan. So first E over m is calculated, and the value of E is divided by E over m, and that comes the indirect value of the mass. Now solution to the question is that velocity is 10 to the power 5 meters per second, E is known, m is known, B is 0.019 Gauss. It is converted into Tesla because 1 Gauss is 10 to the power minus 4 Tesla. In equation, R is equal to mb over BE, compute the values, and the value will come as 0.299 meters. It is an approximation 0.3 meters. So next is electron moving at right angles to the uniform magnetic field completes a circular orbit in a microsecond. That is 10 to the power minus 6 seconds. You have to calculate the value of magnetic field. The period of revolution is given as 2 pi m over BE, and t is 10 to the power minus 6 seconds. So make the subject of equation as B, which is 2 pi m over ET. Now compute the values, and the value will be estimated in Tesla. 3.534 into 10 to the power minus 5 Tesla. At up to 1 decimal place, we can leave our answer at 3.5 because after 5, 3 is not that significant. If it would have been 5 or more than 5, we would have been added 1 to 5. Now, the next example is beam of proton with velocity 4 into 10 to the power 5 meters per second enters the uniform magnetic field of 0.3 Tesla at an angle of 60 degrees to the magnetic field. Find the radius of helical path taken by proton beam. Also find the pitch of helix. Mass of proton is known, 1.67 into 10 to the power minus 27 kilograms. Helix is shown, and the two component of forces are being given, V sin theta and V cos theta. Theta is the angle of inclination of V, and V can be resolved into two components. Then direction of field is indicated by an arrow, and R is the distance, that is, and P is the distance between the helix points. Now R is mv sin theta by qb. Component of the velocity perpendicular to field is v sin theta. Compute the values, and we will find that R comes as 1.2 centimeters. Again, the pitch P, as shown in the figure, will be calculated by V cos theta into T, and T is 2 pi R over V sin theta. Again, compute the values. It is equal to 4.35 into 10 to the power minus 2 meters or 4.35 centimeters. Check out the values of that is components and the helix.